Alright, welcome back to the channel where we are building a video game from scratch using Love2d and Lua. Yesterday we got our frets, oh gosh, like we're working on the timing, right, for the frets. So like, right now, if we hit the first string when any of the notes are within the timing frame. The timing frame is, I call this blue outline the beatbox, which is just like the timing for the rhythm, right? So if the frets are within, I think I did like 12 pixels of this beatbox, then it'll be marked as a correct timing, and then they render green. So what we do need to do is add the other strings timing, because right now we just have it on the bottom string, which I think is string 4. And then we need to check 3 things, right? We need to check if the correct string was plucked in the timing. We need to make sure the timing was correct, so that's 2 things. And then we need to make sure the correct fret was held also. So that's 3 things we need to check in order to count a note as correctly registered. And then we got to make some decisions if we want the game to only, right? So like if we beat the song, or if we clear the song, does that mean you hit every single note correct and only every single note correct, like no mistakes otherwise, or we make it so that you could have a couple of mistakes, a couple extra notes plucked, but as long as you didn't miss any, then it's technically considered a win. I don't exactly know what we should do considering that, but my initial thought is like, let's just worry, for now we'll just worry about, hey, did you hit all the correct notes? So like we'll have like a note count that counts how many items are in our song, and every time we hit the correct string and fret and timing for a note, then we increment that note's correct note count or whatever by 1, so that if we have as many correct note counts as there are notes in the song, then we're registering, okay, you cleared the song. And then we'd have to do some checks to make sure that you can't get multiple correct notes if you've already played it. So like if as it's going you like spam the correct note while it's still in the correct timing, we don't want to give you a bunch of correct note credit. So we'll have to figure out how to do this, because I don't know how to do this. Right now we've got a song 1 that is just a bunch of note instantiations, and we made it so that we can give multiple note instantiations inside a table like this curly brace here. So we can this is how we put in a chord. So a chord of 4 notes is inside a table. We do all that stuff. So it becomes tough when we need to check the correct inputs for the chord objects. So how might we do this? I know we are doing a we should be doing a, what is it called? Correct timing, or timing valid? Valid timing. Okay. So right now, if we press U, oh lordy, let's go back. Okay. Right now, this is for the 4th string. Once we press U, we're cycling through all the active notes. Now, active notes are notes that are currently on the screen. So if by the time you press U, if we have any active notes, then we're going to check if the next active note, so like the leftmost note, we're checking if its X position is within 20 pixels of the left side of the screen. And if it is, then we become valid timing gets true. And valid timing is how we're triggering the color to be green on the note itself. So right now we don't have a way that... Yeah, I mean, the valid timing is kind of nice if we... I'm kind of thinking it's like maybe we should have a missed note field, and if you hit the incorrect note or outside the timing, then the note becomes red because you didn't play it correct. And then if we do something like that, we could either allow maybe 1 or 2 mistakes or allow no mistakes. But that way it would give you some feedback. You know, if you hit it right, the note turns green. If you hit it wrong, it turns red. And if you hit it wrong before it's even on there, then you would incorrectly kind of miss it. That's one way we can go about this. The other idea I was thinking is maybe we can change the string color. So like the notes are always white, but if you hit the note within the correct timing, the string that you pluck might become green. I don't know how I'd like that, but yeah, I don't think I'd like that. And another thing is like we've got right now, we've got the strings turning blue when we strum, but it turns blue as long as it's held. So with something like that, I don't really want the string to only be green the instant it's held. I mean, we could set a specific time for it to turn green. I'm kind of thinking we go the note route, and then we leave the blue as the strumming color. I think that makes sense. So like, let's see what happens if we try to give our note class a different color. So we would need another field in our class, and we can call it invalid timing. Now we can't just use the same boolean because it gets initialized as false. So we would have to make our own invalid timing that gets set to false also, and that only becomes true if you hit the wrong note or you hit the right note at the wrong time. So we can say this, where we can have a similar thing here, where or we can do here. If it's valid timing, set that color. Else if self.invalid timing, then set the red color, and then if it's neither of those, set it to white. So we'll set the color to be equal to red here. So it'd be 1, 0, 0, 1. Okay, so if we are invalid timing, then we will set the color to red. Okay. So let's see where we might put this invalid timing. So if I don't know if we should prevent... Well, let's just try it. Let's just put, you know, if U is pressed and I guess we would just put it here. We would say, you know, if the button is pressed and the note is outside of that valid timing area, then we would want to set the invalid timing to get true. And then we would also want to set this to be false if we have the correct timing. So that'll allow us to correct our red note into a green note. But where do we jack this up? Oh, 44. What? Oh, note 44. Where did we screw this up? Oh. We need an else here. Okay. That should be right now. Okay, so let's see. Okay. We're not getting... Oh, I was hitting the wrong string that entire time. So let's try that again. Nice. So it's incorrect timing until it becomes correct timing, right? So like... Let's see. Okay. That kind of makes sense, right? Like it'll show you, oh, you hit the wrong note. But right now, it's only doing that if you mess up the timing, not if you get the wrong string or wrong fret. So we have to make sure it's only tracking the correct string and fret of our note. So our note does have which fret and which string it's on, so we should be able to check this pretty easily. If we search for when U is pressed, gosh, yeah, my stomach's just been feeling awful lately. Don't know what it is. Yeah. Yep. Okay. So if we work on the first string first, we'd only want this valid timing to get set to true if we're playing the same note, the same string as whatever string U is, right? So if the note's in the area and if the active notes at this first index, so the next active notes dot string is equal to string 4, meaning the bottom string, meaning U. So let's see if we can get that working. So incorrect. It should remain incorrect. Shit, yeah. That's wrong. Yep, that is wrong. So and the active notes dot string. Okay, so let's make sure our active notes is just a table of notes. I believe it is. Yeah. Yeah, so we insert the index into active notes. So the thing that is... What up, K-Chan? How's it going, dude? You know, I'm still feeling bad. My stomach still hurts. Not feeling so much energy. I've been kind of drained lately, so... I don't know. It's okay. How's it going with you, dude? Okay, well that one... Oh, shit. That one seemed to work for all the single notes it worked. So, like, it knows that since I'm pressing the bottom string... Oh, shit. No, that's green. Okay, that is weird. Gosh, and then let me just see. I believe we did strings going down, right? 1, 2, 3, 4 going down. I guess we can check our note and see. Frets. Oh. It would be in our lute string class. Okay. String number. Oh, string number. It's not string, it's string number, and it's... Oh, no, it's... Okay, we do have a string passed into our note. Okay, so it would be active notes dot string. Let me see if we switch this to string 2 and see if that changes anything. I'm looking for that to not turn green, which it is not, except that one on fret 2. Okay, so it looks like our... Nice. Is this for your... Are you... How many classes are you taking right now? I know you've got at least one. But is this, and this is your last semester, right? You're almost done. Two classes. Okay. Okay, so it looks like our frets are working. It's just that for our... Damn, 25 pages. That's when you're gonna... It's gonna, like... You get a ramble on that one, huh? Shit, man. That sucks. 25 pages is brutal. Is it double spaced at least? Double spaced? Size 48 font? Bold everything? Holy shit, dude. That's gross. Yeah, I don't blame you for putting that crap off. But if it, like, that's the home stretch, right? Like, you're so, that's, yeah, that's tough, man. What I always did was, like, I got, like, a basic outline, and then I tried to, like, if it was a 5-page essay, I'm like, okay, I'm gonna have 5 points, and then every page is just, or every point is just 1 page worth. And I just kind of split it up like that. But 25 pages is ridiculous. Okay, so we do want this to be string 4. It's just that, why did the top one get turned green? Oh, that's so jacked. That is not right at all. Let's see if we do string 1. That is... Okay, so it is backwards. Except... God damn it. Okay. I think the string numbers do go from the bottom to the top. We can check by looking at our song 1 here. And the first note is on the 4th string, yeah. At least it's double spaced, but yeah. That sucks, dude. Just make those margins big. Big ol' .48 font. Rambling sentences. Like, thank you for reading my paper. It is very important to me that you read and understand all of the points I'm about to explain to you. First of all, I'd like you to know that today is August 3rd, which I think is a cool date. Anyway, thank you for your time. Let's begin. My first point I'd like to speak about is a very interesting point. I think that you'd learn a lot if you just pay attention to the points I'm about to describe to you in this wonderful paper. That's what my essay would be, dude. Okay. So we do have strings starting at 1 and then working their way up. So 4 is the top string. One thing that is not working is the detection on the chord notes. So that's really quite tricky, I think, because right now we're checking. We need to ask if there's multiple. Gosh, where is it? Right here. So instead of setting the first note, what this will do is set the first note in the index to have the valid timing. Don't cite me. Don't cite me. Don't let that get back to me, man. Yeah, that's yours. That's yours now. I gift it to you. Like, by the way, I'd like to thank Paul for letting me use his attack on the problem. It's a very good theory because the way he explained it was that all I have to do to reach 25 pages is to start off by talking about the methodology of which I am going to be talking about today in this very paper. Thank you for your time. If you don't know how to read, I'd like to point out that there are lots of different things that go into reading. First of all are words. Well, actually, first of all is letters. Here is a list of every letter I know in every single language, thanks to ChatGPT, source in bottom. Okay, instead of doing this, shit. If we have more than, yeah, and don't forget the 48-point font. That's the most important. If the value that is inside the index of an active note is more than one value, that means it's a chord. So we would need to so we need to do this stuff only if there's one note. But we need to do something different if there's multiple notes, right? So I think we're doing something like this already. I'm trying to think right here. So look, if we say if the number of values in this active song is greater than 1, meaning it's a chord note, then we're going to cycle through all the chord notes and do something to each one of them. So we're going to do something like this. So let's say if we have an active note, then we're going to then check if that active note is a chord. So if the next note at index 1, so the index of our next active note is greater than 1, meaning there's a chord, multiple note instantiations in that spot, then we're going to cycle through the active notes at that first index to go check all of the notes. So we would need to go cycle through all the active notes and then do something exactly similar to this, which is then we need to check each one of those notes if they are in the valid timing range and the correct string. Hey, thank you for the sub, dude. I appreciate it. Thank you, man. Yeah, it's always nice having you in here, dude. Okay. So we want to do the same thing as this, except not at index 1, but at index 1 dot key. Is that right? Key, yeah. Key is the index of which table we're at. So if we're in the first note and we check, oh shit, yeah, we'd have to cycle through each note here as well. So we'd put the key right there and then also the key right there. We aren't checking the frets just yet, but I don't know if this is going to work. So the idea is we need to check this stuff. Okay. Let me leave some notes here. So like this is if there are active notes, then if next note is a chord, and then the else here is if next note is single note, and then if the, yeah, we need to do an else here also, because if it's outside of the proper timing, then we need to become actively invalid timing, which will become red, and valid timing becomes false, so that we don't accidentally get more than one color set or anything like that. So as we cycle through, well, we can put here cycle through all chord notes. Okay. So anytime the first string is pressed, if there are active notes and the next active note is a chord, we're going to cycle through all those chord notes. And this is the index 1 is the next active note, and index key in that first index should be the note that we're cycling through. So that's the 4 key, value in pairs active notes. If the vary notes .x is smaller than 20 and it's the correct string as a pressing U, then we're going to go ahead and set valid timing to be true. Otherwise, we're going to set invalid timing to become true. So let's see if that works for chords now. Now it should only turn the top chord green. Oh, maybe this is the right one. So, shit, we messed that up. Shit. Yeah, the bottom string, shit, man. Okay, did we have a lone note at the very bottom? I don't think we did. That should be string 1, okay. Yeah. Shit, it still is red, but let's go to our song 1 and give us the very first note is actually on the first string, so that we can test if at least a single note works by turning green. Let's see. Oh my gosh. Why does it do that? Okay, so the note, I think we swapped the strings in our note class and in our lute string class. So let's see if that is the case. Because I think in our lute string we have it 1, 2, 3, 4, but in our, well, let's just see. Lute string, we have a string number and we are rendering the lute string at the atlas quad. 0 is X, and then the string number is, oh my goodness, look at that. The string number multiplied by the string lute spacing plus the string Y offset, and then minus lute string spacing. So we multiply by it's so jacked up, man. Oh, okay, so this way means that the higher the string number, the lower on the Y axis it is. So that would be string 1, 2, 3, 4. But when we were doing our note render, I think we did screw this up. When we were doing our note render, our string here is fret 1 has no string offset. Oh god. Okay. Okay, well, this looks to be the same. Yeah, because the higher the string number, the lower on the Y it is. So why is it that we have the incorrect timing rendering? Oh gosh. So like the first note here is on string 1, which is the top string, but U being pressed. Dude, see, and that's what's weird. U being pressed is triggering the top string. Okay, so let's see here. If we go to our play state and we check for U being pressed, okay, so let's say if U is being pressed, that's actually string 4. So let's see. We should have a red square for this first note, no matter what the timing is. It shouldn't go green. Okay, good. Okay, good. Now, does the last one turn green? It does not. But if we put the first note to be on string 1, Oh, actually, yeah, this is backwards. Because look, if we put 1, then the lute... Oh. It goes fret, then string? No, it goes string and then fret. So why does changing the string... Yeah, we're not even changing the string here. Anytime we change this number, we should see a different string for that very first note. Let's try to change it to the 4th fret and at least change that. Yeah, the 4th fret, but it is always on the top, no matter what string we give it. Oh, well, now it's working, maybe? Maybe I just wasn't saving it. Okay, so let's see if this turns green in the right timing. It does not. Shit. So that's string 4. See, and that's what's screwed up. We're counting... This is jacked up, because we're counting our... We need to swap the rendering for this. Either we need to swap the rendering in our lute string or in our note. Because right now we are referencing them different. Because 4 is the 4th one down. 1, 2, 3, 4. So 4 is the bottom string as far as the note instantiation is concerned. But when we go to render our lute string, this is only turning valid timing based on, look, if we give it string 1 instead of string 4, it doesn't know. Shit. Okay. Another thing that's wrong is it's only changing the color for the very last of our chords. So when we render, we have to go through and check every note, like we're doing here. So what's bothering me is that we're not even getting... Oh, well, we didn't change for the single note down here. Let's put string 4 at the bottom here, because you should be string 4 as far as the note is concerned. So this should turn green by the time it's close. Okay, nice. And none of the other ones should, except this bottom one. Okay, and it does. So that bottom one is fine. But what we aren't doing is we aren't updating the colors for all the notes in the chord notes. It's only rendering that bottom one because it's last. So we do need to go... I don't even know where we would do that. We are updating every string. Okay. We would need to... So where are we rendering our active notes? Right here. Okay, so this is probably where it's going wrong. Well, see, and this was one thing I was confused about earlier, is we're rendering all of the values in our active notes table. Now, our table has a bunch of notes as well as a table of notes from any chord objects. So it's confusing to me why we're able to just say in pairs active notes, go ahead and render, and because we know we're rendering them, we can see the actual frets. But yeah, let's check our note class and make sure, yeah, this is where we're drawing the frets. So yeah, our notes are the frets that we're drawing, and we are doing that. And now we should, I guess the only thing is we might not be updating any active notes that have more than one objects in them. So let's go see if our active notes, by the time we're updating them, well, we do update them here. That's updating the timer, but it's not updating the note instantiation. Okay, so maybe we aren't updating them. Yeah. So what this does is this gives us the next song's note inside the active notes. And then if it is just a chord, we're just going to get that one single note into that active notes. But what we aren't doing is updating those. No, we are updating them manually over here. So we must have screwed up something here. No, okay. I think this might be right, actually, because we're only checking the timing for the note that matches the string that we're strumming. So I think if we add the other... look at what Jimmy's doing. What is Jimmy doing? Jimmy's been laying eggs, so Jimmy's been burrowing and burying herself. So yeah, she's been kind of digging lately. I think this might be right, actually, because the fact is we are updating the correct bottom string, but none of the other ones, which makes sense because we're not strumming any of the other ones. So how do we know we don't hit the wrong note because we didn't hit a note for that string? So the other thing we could do is if you miss... I don't think we should turn them red if you don't strum, even though that would be wrong. It's just that they're not red until you make a mistake, and you don't make a mistake until you strum that string or not. And by the time it's off screen, maybe we can set the invalid timing to be true if the note leaves the left side of the screen. So if it's less than 0, then maybe we set the invalid timing to be true. But let's add this for the other notes. So right now we only have, if U is pressed, we have this stuff, but we need it for all of these strings. Oh my goodness, what is this? Okay. String 1. Before we do any of the fret stuff, we need to do the invalid timing. So if I is pressed, I is our second string. We're going to do basically the same thing, except we're checking if the string is, if it's the second one from the bottom, our note thinks it's string 2. So we'll check for string 2 here. And if string 2 is the note that we strum, then set the valid or invalid timing. So let's see if string 2 works on the chord now. So let's see. Well, it should work on this second one as well. So, oh no, we did that backwards. Oh shit, yeah, we aren't doing, oh god. Yeah, it's actually string 3. See how we're only turning the chord note? We're only turning the very bottom chord note to an invalid timing, so we aren't doing this part correctly. Okay, I think we should go into our song 1 and give us the chord note sooner so we can test this sooner. And we can put our chord note at the very first spot here so that we can test it sooner. So I'm going to try strumming them all. Yeah, it doesn't register the wrong note either. But it should have picked up the green note on the bottom one, but it did not. Okay, it did that time. What up, Magnetonics? How's it going, dude? Yeah, it did turn it turned it to false awe, and I don't know. Oh. Okay, see, this is tricky because I think we also need to only flush the invalid timing if the string is the same string as the one we're pressing for, so that we don't accidentally flush the value when you had the right. Gosh, that's confusing, but I think that makes sense, is to also to check only if the string is equal to 4. Then we go ahead and set the invalid timing, and then I think we do it here as well. Now I'm sure there's a way to turn this into a function so we don't have to do the same code, but we're just trying to get it to work first, and then we can make it prettier. So we're going to say also if the active notes dot string is equal to 4, then do the invalid timing. So if you hit the right string but at the wrong time, then it's invalid timing. So now we should hopefully get the 6 hours is killer, dude. Good job. Nice. Okay, so we've got the correct correct notes for 1 and 2. So I think this method's working. Was this a programming stream for 6 hours or a miscellaneous stream for 6 hours? Okay. I'm trying to think how we would turn this into a function. Because all of this junk should be a function that takes in only a string number. So let's try to turn this into a function that takes only a string number, because this is all duplicated code. So we'll yank this. Let's just for now go outside of our update. And we'll put all of this code into a block for a new function called active note checker. No, it would be called valid note checker. Okay, takes in one argument of a string, and we can place all of this into the valid note checker. Okay, why is it... Why is it mad at us? Valid note checker function. We must just... Oh, we need an end for here, I think. Okay. So our valid note checker is now that. Now if we go back to where we check this stuff, all the stuff is the same. Like, we check if there's an active note. We see if the next note is a chord, so because we need to cycle through each of those notes. If it's not a chord, then we go and check the valid timing for only the next note. The only difference being this dot string being equal to a certain value, and that's where our parameter string comes in. So looks like we just missed the end. Yeah, it looks like we missed the end when we copied this. So let's continue onto our function and just flesh it out, because all we need to do is check if the given string is the same note as the notes string. So we put in our parameter string there and string here. And then we should be able to use this function for every single note check. Just giving it the current string that is being pressed. So let's go to our code here where we use that. Yeah, right here. Instead of doing all this junk now, we're gonna say, let's just put in our valid note checker. And the first one, oh god, let me see. The first one was a string 4. So let's put our valid note checker with a string of 4 in there. And it's not a string, it's technically a number, but let's see if the first note is working for that with the new valid note checker. So yeah, it registers that it's wrong note, and then it should register that it's a good note. Okay, sweet. So now all we should have to do is use our valid note checker on every different string, giving it the proper note number. So I is 3, meaning O should be 2, and we should be able to delete this. And then let's say that is so much nicer, right? Valid note checker, O should be 2, and then oops, we should be able to say that P is 1. Okay, let's see. See, that's not right. That should... Shit. It's not quite right. It's not getting the invalid notes anymore. I have not tried any 3D stuff in Love2d. One of the guys that comes in every once in a while, Prosto, he does, like, he's doing like a Minecraft-like love game. I didn't see what happened to Jimmy. Did she climb? Did she climb down? Or burrow? I didn't see. This isn't quite right. Let's try only string 4 here. See, that should not highlight that. Oh god. I think we messed up the string order. Cause P, let's try giving P 4. Are we sure? Okay. Let's turn every valid note checker off except the first note, so that we can try to debug this, because I thought this was working. Okay, we're only checking U presses for a valid note of 4, so let's try. Okay, that looks right. The fourth note, okay, so that registers as green. So let's try to check only I now for a note of 3. See, that's wrong. Oh, and you know what it is? Well, we give in our valid note checker function, we are checking. Oh, yeah, this is really wrong. We need to put the string right here, the parameter string, because we were hard coding it in at 4. So now that we're putting it as string, let's see if the third one. Oh, see, that's not right. It should be registering. Oh god. Oh. Okay. I think I just screwed up which string was what, because it looked like look, valid note checker. I is on string 3. Let's try it on string 2. Let's see if that works. Nope. Why that one? Why that one? That was string 2, so I should be string 3 like I had it. But that third note from the top should be red right now. See, that one works. Ah, flip. Let's try the other one and see. We might have screwed up. Let's see. Valid note checker 2 on O press. Yeah, see, that should be red. Because we missed the timing, right? Why that one? Why that one? You got one of those notes. Yeah, I don't know, dude. I don't know, because I'm only checking, like, I don't know. I don't know. Let's check one more time. Because the thing is, the function works for pressing I. No, for pressing U. If we leave the U press on a valid note checker 4, that one works. See how it's red right away, and it's not green until we get there. That's okay. That's good. Okay. So that one's working. It's just that if we do any other string number, it's wrong. I don't know. Let's see. I'm gonna try to put valid note checker for 4 on an I press and see if that turns anything red, because it should. Okay, it turns the wrong note red. Okay. So, okay. Well. And then when we put 3 in there, see, that should turn it red, but it's not. See, why did that one turned the note on the second from the last string? See, it should be red there. Oh god. See, oh yeah, it's not working on the chords, so why is it that it works on the I think there's still yeah. So we are doing I think it is in the chord check, but and what's interesting is I think it's not messing up on the bottom one because in the realm of the loop through the notes, if it's a chord, if we're looping through all the chords, okay, this is confusing because it's like if what we're calling a song is a group of notes, the first note could be a single note, the second note could be a group of notes like a chord, then it makes sense that the bottom note of the 4 chords is the only one working. So I think it is in the... Dang, dude, 6-hour programming stream. That's epic. That's awesome, dude. Yeah, I think we just messed up this thing then. So let's walk through. If the next note is a chord, we're going to cycle through every note of that active note, and if oh, okay, so we're only running this valid note checker whenever we press a string. And when we press a string, that's when we know what string to pass in as a parameter. So if the string matches the string number, oh gosh, this is so confusing. So we're cycling through the active notes, which that's only happening if there is a chord. So if there are multiple stuff in there, then we're doing this part. And what we're doing is cycling through each note and seeing if each note, let's see if the first note is within this active timing and that the string is the correct string. So the dot string of this active note is which string the fret is on, the actual note. So like the actual note is only rendering a fret number and a string number. And we're seeing if the first note is within this timing, and if it is in this timing, then we make a valid timing true for that note. Yeah. Well, I guess what we could do is instead of saying this, I think we can do v.invalid timing for all of this. Because V should be the note object. I think we should be able to get away with that, but I don't know. Let's see if we put V there, if it changes anything. See, that should be red already. Okay, shit. Yeah, it'd be nice. It'd be nice if we can get any other note other than the last one to be working. Because that's what's not working. But it does work for the last note, which is weird. So I'm kind of wondering if we have a note with only where the bottommost note is a third string instead of a fourth string, if it would work. And my camera's all jacked. Why does this happen to me? Hey, good night, Magnetonics. Thanks for coming in. I'm trying to get the freaking... Come on, man. Okay, that worked. Why? I don't know why that worked. Yeah, have a good night. Good job streaming today, dude. Okay, so yeah, let's try that. So let's go to our song 1. And we're going to make sure that our first note only has 3 notes, not 4. And then we're going to see if doing our valid timing or valid note checker on an I press. So we're not doing a U press, we're doing an I press on valid note checker 3. Let's try that. Oh, we gotta check. Okay, so that works for a single note. Does not work for the multiple notes. So the valid note checker is working for all but chords. So it's just that, yeah, it only works. That is so weird. If we go and make sure our third note in our... Okay, so the first note in our song 1 is a chord, and if we make sure that last note of the chord is on string 3 instead of string 4, we should be able, or let's see if we can get... See, that isn't right. We want the last third string, second string, fourth string. Okay, so let's try 1, 2, and 3. Okay, let's try that. I'm hoping that the bottom note will turn red here. Ah, it doesn't. Only if it's a single note. What the heck, man? So yeah, I mean, we're just jacked up here. If we have a note that's a chord, we're going to cycle through the notes, and if the very note... Yeah, okay. If the first notes in there, otherwise invalid timing becomes true. Let's... I think this is jacking it up. Well, let's just see. If we take out the else... Let's see. See, that should be red already. Okay. What are we missing? We're going to cycle through all the chord notes, and if the first note on the first loop is in the active note timing, it's going to go set that note's valid timing to become true, which should change its color to be green. If it is outside of this timing and the note is pressed and it is part of the chord note, then we're going to check if the string is equal to the string, the note's string is equal to the string that we just played, and if it is, then we're going to say invalid timing on that note. I don't see what's wrong here. Yeah, I don't see what's wrong here. I just know that it's our function's only working on the first or on the last fret rather, and that's what I don't really get. It only works on the last fret if the last fret is the fourth. For number of active notes is greater than 1. Yeah. I don't see what's wrong. I'm getting a little desperate here. Okay, I'm going to hard code in that the first note is being manipulated. We should be changing the very first note of a chord to become valid timing or not. So as long as we are pressing, let's do I. If I is pressed and we're running note checker on 3, let's try that. See, yeah, that's so wrong. Yeah, something... Why is it not working for any of the chords? Except when U is pressed. What the heck, man? See, that one worked in the chord. Oy, this is so weird, man. Okay, maybe we go if we go to our valid note checker, maybe we only check the string that we are currently on. So like, instead of saying cycle through all the notes, we want to first cycle through and find if that active notes at that first index, at that keys index, if that dot string is equal to string, that's the first thing we're going to check. Then let's just bypass the valid timing check for now, and we'll just set that string's invalid color, oh come on, invalid color to be false. Let's just do this. Let's just try this and say all we're going to do is we're going to cycle through all the active notes, and if that note's equal to that same string that we just pressed, if there's any note in that chord that has the same string as the one we are pressing, meaning I, meaning the second from the bottom string, then we're going to set the valid timing to be true. So it should be green if it's a chord and we just press it, which it is not working. So like the chord one doesn't work, but the single one does. What the heck? We've got to be doing something else incorrectly in here that's like overriding this. Do a valid note checker, valid note checker. Let's just take this one off and see. Valid note checker for 3. Let's just try to put it on 2 and see. 2 should be... Okay, it only works on single strings. What the flip, man? This all went down when we tried to functionalize this, but I don't think that's the problem. Let's hard code in instead of... Gosh, man. Let's just try to take out this parameter and say if the string is equal to the second string. I just don't get why it's messing up. So like this one is right? If it's a single string, it's working. So the only thing that's not working is this looping through all the chord notes, yet... Yeah, this should be looping through the table. That should be right. We should be able to even do the V dot string there, but it is not liking it. So we hard coded in at string 2. So let's go to where we press string 2, and let's make sure that we only have no parameters in there. Come on. Okay. No parameters. We're only checking string 2. Let's see if chords work. No. All right. I don't know. I feel like we got to just start from scratch again on this. Let's just try to change the color of every... Gosh, man. Okay. Let's just gut this. And we'll say if the next note is a chord, let's just see if we can turn all of them red or all of them green. Just can we change all of them? So we're going to do a loop here for key value in pairs of our active notes at our index 1 because it is a chord. We want to do something, and what we want to do is say that the valid timing gets true on that note. Yeah, we're not even able to change any of the chord colors. Well, are we even running a valid note checker on any of the button presses? We are not. Let's do valid note checker. We are, yeah, I guess we weren't. Okay, let's see. Yeah, this should be turning them colors, like... Let's see if we're doing anything weird. Oh my gosh. Why is this? What am I missing here? So our valid note checker is gonna... If there are active notes, and if the active notes first index has more than one value, meaning it's a chord, is that wrong? So like, what if we just say, oh my gosh, man, I don't know why this is so difficult. Let's just say active notes at index 1 dot timing, and let's just say we have to do some sort of check here because some active notes have a second index to go into. So we're just going to say if the number of active notes at index 1 is greater than 1, then we want to change that active note at index 1, active notes at index 1. We actually want to loop through, and we're going to say for key value in pairs active notes, we want to say do. We want to change the active notes at that index 1 at that index key dot timing, valid timing, to be equal to true. And then if there is not a chord in there, then we just want to change the active notes at index 1 dot valid timing to be equal to true. We should see some color change here. Shit, man. Okay, get length of nil value. You have to wait till notes appear just to press it. Okay, so we are changing the color. So now the thing is, can we change... Why did it only change the color of the first note? It should have changed all of them. It should have changed all of them, and I think this is what is messing up here. We're not looping through the correct note here. If we try the value.valid timing to be true, let's see if more than one turns. Just one. So it's working, see, and then why the bottom one that time? What the heck? Okay, this is weird. See, it's a chord, but it highlights the first note, but then on this second chord, it highlights the bottom note. Let's see in our song if we're adding any. This is a note 1 on the string 1, and then on our second note that is a table, we do a note 4. Okay, so it looks like, or string 4, yeah. Shit. So it looks like only the first string, only the first value is actually being changed here. Because if we were to change this order around and put 4 right here and 1 right here, then both of our top notes should be turning green as long as we press U once there's active notes on screen. Okay, so now the top one is green. Now the top one of our 4-note chord should also be green. Okay, so we are not looping through all the chords, all the notes in the chord. So why is that not happening? If we have more than one, valid timing.true, and if we turn this off, nothing should be green, right? God dang, okay. Let's go to song 1, and we'll make sure that our second solo note, or our first solo note, is actually on string 1, so we can test that. Okay, so we're not rendering a color here, but on the second solo note we should be, and we're not. What the flip? Oh, we turned off. Okay, we turned off the valid timing. So it looks like the valid timing was only working. Look, if we turn off this one, we should be getting, what, the green note on the top note still? What? Why is you taking so long? Okay, so it's only checking. Oh shit, this one isn't even running. How are we doing this wrong? Okay, I wouldn't have guessed that that's what was happening. So it doesn't know that we have more than one value. So if the number of values is greater than, what, greater than 0, it still does that. Okay, we're just misunderstanding how to check if there's a freaking chord in the notes. So let's see if active notes should be the next note that's coming up. And we do this if the number of song index 1 is greater than 1. We're going to go insert the active notes. Okay. Wow, we don't have a method to cycle through all the active notes? If it's a chord, what? See, this is what we're doing, is like we say, okay, I think we might be not populating our active notes correctly. No, because we're printing up the number of active notes, and that is correct. So there should be at least a value that's correct, but maybe it's the wrong value. If the next, this line here says, if we have a value left in our song, which we should probably do this if greater than 0, then we're going to cycle through all of the values in that first index, and we're going to insert into our active notes. Okay, so I think what I want to do is turn the debugger on and just print up what our active notes are, and just make sure there are more than one value in the... Oh, look at Jimmy's head. Jimmy's head is right there. Here, I'm going to turn the camera. I don't think that webcam has focus, but there's Jimmy's head now. She's so cute. Okay, let's go on and turn our debugger on. Shit, man. This must be going wrong. This must be going wrong. Let's go to our love.conf. conf.lua. Or is it? Okay, we're gonna turn our console on. And we're gonna go run our game after we print our active notes table. So let's go to the bottom here and we're just gonna say print our active notes table. Okay, let's try this. I don't know. It looks like they're in there. It looks like they're in there. It's hard to tell because it happens so fast. Maybe let's just print up the number of active notes and see if that looks right. 3, yeah, 4, okay, 5. That looks right. Yeah. Yeah. That looks right. I don't know. I'm really kind of stumped. Because, like, I can't even do a simple thing, which is, like, just turn all the notes green, you know? We should at very least be able to do that, but we are not able to do that. So, let's... Maybe we can print up... Maybe we can do an on-screen debug and just print up the string and fret for every note in the active notes table and see if that's valid, and then that can help debug if it's correct or not. So let's go. What are we currently debugging on screen here? We've got the song 1. Yeah, we don't want the song, we want the active notes. So let's do active notes, and we will inspect only the next active note, and we will loop through. Let's loop through and make sure this is working. For key value in pairs of active notes, we want to do print on a active note index 1, the first active note, but we want to print up every note of there, but we want to print up every string of that active note, and we want to manipulate our Y to be 75 plus K times 5 to give it different offsets so that we can see an active note active note and nil value. Active notes right here. Okay. Let's only do this if we have an active note in the table. So if active notes is greater than 0, let's go ahead and try to cycle through and print out the string number for each active note. Oh man, dude. Okay, active notes at index 1. Okay, we must be screwing this up. We must be doing this wrong. We must be able to say v.string or something here. Okay, so it is the v dot. Okay, so we're printing up the string for every active note. Oh, this is wrong. This is wrong. Oh, let's just say we want to loop through. Okay, so let's try one more thing. So it looks like we do have to do the V string. We can't do the index, which is kind of weird. I thought we could, but let's try instead of cycling through all the keys in our active notes, we only want to cycle through all the keys in our first note. First active note. Let's see. Okay. And we don't have a... Okay. We only want to do this if our active notes is greater than 0. Okay. Well, then... Okay. So now we can say if our active notes at index 1 number operator, if the length or if the number of values inside our active notes is greater than 1, meaning there's a chord in there, then we're going to go ahead and render the chord, all the chords, and then else we want to just print up the single active note at index 1 at index whatever, 1 times 5, whatever. Let's see. Why are we getting... This is so wrong. Let's just try to print up the chords. Let's see. See, there should be a note on screen there. What the heck? There is something really, really wrong going on here. Like, really, really wrong. What is going on? This is like really messed up for some reason. I'm gonna say active notes number here. And we just want to count the number of active notes we have. If we have more than 1 in the table. More than 0 in the table. And then let's do this here. Okay. Let's just make sure the number of things is looking correct. Yeah. So like the number of active notes looks correct. So let's go in and only say, so if this one looks correct, let's just say, you know, we can leave ourselves little notes like this looks correct. Now let's try doing active note at index 1 dot string, and we will say, and see, and this is jacked up because depending on if there's a chord or not in the first active note, it's going to cause this to either crash or not. So I'm going to say that we have to check both for if it's a chord or if it's not a chord. So we're going to check if the number of active notes at index 1, if the next note's got a chord in it, meaning it's greater than 1, then we want to print up not active notes at index 1, but active notes at index 1, index 1. So let's just see if we only print the first string of... See, we should be printing it there. And we're not. We should, let's try to do here where we say, let's just print not the inspect, but to string in active notes 1 string. Let's try that. We don't have it. So let's see if we can say else. Let's just go ahead and print up the very first active notes at 1, 1. Let's try this. Let's see if anything shows up. Okay, that does work. So we're fundamentally not being able to render any or touch any other note. If it's a chord, we can't even touch it. I don't get why that's the case. We have to do, it has to be something with right here. If the number of active notes is greater than 1, this has got to be wrong. How would we check this? If active notes at index 1, I thought for sure, and the thing is, we're printing out the number of active notes. So let's say the number, oh, okay, let's try this. Let's try to print up the number of active notes at index 1. Now, this might fail if it's not a chord, but let's see if it does. Okay, that is so wrong. That's why it's not working, is because we can't even count the number of active notes in here. So how do we get the number of how many objects are in our table? I thought we can do this. See, and that's so weird because we're only printing up this number active notes if the number of active notes is greater than 0. So once we have an active note, we're trying to print up the number of active notes at index 1 is what we're really printing up. And that is always 0 for some reason. That is so wrong. It should be how many notes are in there. So why is this wrong? This does make sense why everything else was broken, though, is because this method of getting how many values are in there is totally jacked up. So we can, wow, yeah, if this isn't working, we have to be able to call like a dot length on the table or something and see. I'm going to do a search for Lua table.length. And it was just this number operator, I'm pretty sure. Prints the highest number in the table. Oh. Yo, this is not what I thought it was doing. I think Prosto told me this once. So it looks like the number operator only prints the highest value. That is so weird. So how come we can't... Yeah, how do we return the length of a table? This is so jacked up. Okay, let's check some documentation here. Lua operator. This returns the length of the a string or table. The length of a string or a table. Okay. But if that table's full of classes, it doesn't return anything. This is so weird. Lua, how to count items in a table. Get and what the heck? What the heck is luau? Okay, I'm gonna have to look this up off stream probably, but let's try to do this differently. Let's try to loop through. Yeah, let's do this all different. Let's just say, I'm gonna get rid of all this junk. Okay, what we want to do is loop through all the items in a given table of active notes at index 1. And we did that wrong. We have to say key value in pairs, active notes 1. So I'm curious if the note isn't a more than one value, if it just stops there, but let's try to have a count here, and we'll say count gets 0, and then actually we'll do this here, and for every value in the pairs of active notes, we just want to increment our count. And then what we want to do is print up the current count, and we'll do this love.graphics.print, and we'll put it right here instead of the active notes. We know that's working. So let's take our print after the loop and say number of active notes. And I've been thinking about that operator all wrong. I thought that would always count how many items in the table there are, but what it really does is return the highest value in the table, which it makes sense why only the bottom note, only the bottom fret was ever turning green, because we were only ever going to that one. So we're going to say print the number of active notes, and we actually want to just print up the count. Oh, we want to print up, yeah, number of active notes, and then we will concatenate it with our actual count that we are now doing. So now this should be the number of notes we actually have, not the number operator or whatever the heck Lua calls that thing. So let's see. It doesn't like it. It doesn't like cycling through. So we want to only do this if there is a value in our active notes table. Then we want to go ahead and do this. Okay. Wow, that is so wrong. Where did it get 7 right off the bat? Because we are not updating it, but why would it get 7 right off the bat, man? This is so wrong. It is doing this every frame. Wow, this is so wrong. What the hell, dude? All right, let's go check out our active notes table. It's an empty table to start with. And then, yeah, ignore that. Okay, so oh my god. Okay. So what we're doing is we're putting every note from our song, every next note, whether it be a single note or a chord of notes, into our active notes table. I think this Yeah, this is wrong. We need to be able to say, because we're putting in the one note. If it's a one note, we put that one note, a table.insert into our active notes. But if there is more than one note, we need to actually insert this into the first active notes, I believe. Because we're trying to table.insert them all into the same table, not insert, which would... I always get this screwed up. I think insert appends to the end of the table. Crap, now I'm thinking of JavaScript. I don't know. Let's see if this number is correct now. No. No. Table, playstate 82. We are so jacked. I might need to pull this open in Zero Brain Studio so that we can debug this active note table. I think that's what we're going to do. Let's try to do that. Let's pull up our Zero Brain Studio. And we'll open the game in there, and we should be able to add a watch value for the... Is active notes a global table? It is not. Okay, so let's open up our playstate. And let's see if we can add a watch value on active notes. So let's say add watch value. Okay, now let's run the game. Let's watch this active notes. Nil. Oh god. It's just not updating. Okay. Let's try to make it global and see if that changes anything. Do we have to... No. Let's try to add the watch value. Oh gosh, man. Yeah, let's add the watch value on this, which counts how many active notes there are in the first active note. No, I think we're trying to figure this out better. So let's just add watch expression here, and let's try it again. It's just not updating. Okay, well... Thanks for nothing, Zero Brain Studio. Let's try to do... This is probably wrong now because we just changed it. Let's go back to our active notes. And we'll make it local again. And now let's go back. Did we turn our console log off again? Let's just try to... Oh my gosh, man. We want to see what values are in our active notes table, because we want to make sure we're loading them correct. So yeah, I think what I want to do is let's forget all this and let's just print up active notes. And it's not a love.graphics.print. We want to print this to the console, so it'll just be print. and it'll be active notes at index 1, if there is one, right? Well, index 1, yeah, because I think we're inserting them wrong, so I think on any chord, they're going to be messed up. So let's take out our chords first, and we'll just try to print up the string of the next active note, and that's all we'll try to do. So we'll say active notes at index 1 dot string. Oh my god. And then we will, yeah, we'll just print up that. Let's go make sure our conf has console true, and then we will run our game. Oops. We'll run our game so we can see the console here. And we can't index a nil value on 553. Okay, so we only want to do this if there is a value in our active notes, so we don't crash there. That is the one thing about Lua that I just always run into, is the indexing a nil value always makes you crash. Okay, so string is 1, because that's the first note. It should become 1, and then it should become 2, then it become 3, yeah, then 1. Okay, so active notes at index 1 is working, and that works regardless of if there's a chord in there. So that's at least working. Yeah, that's working right. So let's now try to see if there's more than one note in our active notes table, and I don't know if this number operator actually works in this way. Let's just try to print up the same thing, but only if there's a chord. So there's a chord, it'll scroll, and then it should print nothing. Okay. Oh. That is wrong. No. Oh, no, that makes sense. That makes sense. It would still scroll. Okay. So let's try to say if there is more than one note in the first index of our active notes, then we want to debug. So, like, let's see that. Oi. Let's say also here, if the number of active notes at our index 1 is greater than 1. This is so weird. Okay. And it only, that's so weird. It doesn't work if I'm full screen like that. I don't know why. Oh, it doesn't work this way either. What the heck? Okay, so that is wrong. We can't be doing that. Because that's not even... So if the active notes... How do we say... Oh my gosh. Okay, so the question is... If there's only one note, we want to print up only that first note string. If there's more than one note, we need to cycle through all of that index, count its tables, so that we know, well, shoot, man. Okay, let's say how do we do this? Okay, let's set a local count. Then we will cycle through all of our active notes at our index 1. So all of our first notes Because this checks, hey, do we have an active note? This says, okay, cycle through every active note in that first active note item and do something. And the thing we want to do is print up not only the string for index 1, but we want to print up the string at index k. No, the v dot string. Okay, let's see that. V dot string is a Boolean value. What the heck? That should not be the case. Why would the string be a Boolean value? We give it a number. Okay. So that printed up. See, why can't we put a v dot string here? One and 0 in C. Like, man, I am so confused here. We aren't doing shit with the count yet. So, like, let's just say all we're gonna do is increment our count for any active note we have in that first note, and all we want to do is print up the count. Just to see if we're actually counting how many active notes we have correct. Why? Oh, that's so weird. I guess we need to print up the count only after the loop is done. See, that is just wrong. We must not be flushing our active notes correctly, because that number should be getting lower as they go off screen. Well, let's see. And then we're resetting our local count to 0. Oh, well, let's try to set it to 0 here. See if that makes a difference. Yeah, this is just not right. We shouldn't have 7 active notes. Zero is false and 1 is true. In Lua? Hey, thank you for the follow, Wellsry. Appreciate it. I'm not making too much progress today, but at least you can watch Jimmy. I'm not sure what you're saying, Puny. 0 is false in Lua and 1 is true, but are you saying right here, since we're saying greater than 1 here, that thinks it's, if it is true? Is that the misunderstanding that I've been having this whole time? Because I was thinking that this number operator, not Lua in C. Okay. I mean, I don't get this number operator in Lua then. Because I thought this counted how many tables were in the table that you ask it, but it is not doing that. So I don't think we're clearing our active notes correctly, but what's so weird is as soon as we have one note, our active notes turn 7 and they stay at 7. It should be 3 at the very beginning. So why is our active notes here? Okay, we have an empty active notes. Ignore that. Okay, so it's got to be jacking up here. So we have a song timer, we decrement it. If it's smaller than 0, then if we have... This has got to be where it's screwing up. Where's the 7 coming from, though? I don't get where the 7's coming from. So if we don't insert any of those values, what is our count? 7. What the... 1, 2, 3. And then it took out... Okay, so it looks like... This is so wrong. So I think the 7 is coming from... I think the 7 is coming from how many notes are in our total thing. So like, there's 3 there, there's 4, there's 5, there's 6, 7, 8, 9, 10. Okay, I don't know where 7's coming from. What the heck? This is so wrong. Let's do this differently. Active notes is just so jacked up. I don't... Well, what's weird is we know we're rendering them correctly, and we know we should be deinstantiating them correctly, but we are not. Now, when we do the number operator there, it gives us the right number, which I thought was proof that active notes was deleting correctly. So let's just print up the string for active notes index 1, if it exists, and see if it changes per string. So like, let's say print up active notes index 1 dot string, and we'll say toString active notes index 1 dot string. Yeah. So our active notes, our first active note table is correct. So what the flip, man? It's just that when we try to count them, okay, so I think the 7, okay, I think the 7 is coming from the amount of tables inside the note instantiation. Let's see if that might be the case. 1, 2, 3, 4, 5, 6, 7. Okay, so if it's a class, then the number operator just gives you how many things are in the class. Okay, so that helps me. So that's where the 7's coming from, I think. Let's test that theory. Oh lordy, that's not right. Okay, we've got count here. Let's go to our note class and we'll just say self Jimmy gets true. Now is this 8 instead of 7? It is 8. Okay, I did not think that was the case. So when we go through here, man, this is so weird. It's almost like we need to... Yeah, this is so wrong. This is not how I thought this number thing worked. And the classes don't make it work nicely either. So, how do we do this? We've got a table of note classes, and each index either has one note or a table of note classes. Now we're not able to go into the chords. Any note that is more than one note instantiation, like a chord, we don't have the ability to go and index into it to go change its color to see if we played it correctly or not. So we have to figure out a way to do that. And I'm super stumped. Now, this number, actually, yeah, when we cycle through, this is so weird. So doing a cycle through a first index is actually going inside the class and cycling through how many fields it has. I thought what it was doing was cycling through all of the table, which if we only had one note in the first index, it would only do a loop of one, but that is not the case. So we need to figure out how to loop not through the init fields. Yeah, it's all table. So it's like when it says loop through active notes at index 1, it's like, oh, you mean all of the fields in that first index? Instead of how many classes are in the first index. Man, I don't know how to do this. Because what we want to do is, if we have a chord of notes in the first active note slot, that would be 3 classes. So maybe we say... Oh, shit, man. I mean, I don't like the... I don't know what we do. Part of me is like, just divide the count by 7 once you're done. Then you have the right number. That is so jacked up. Because what we really want is, if there's a chord of notes, we want to be able to know how many notes there are in the chord. So that is jacked up. But then it never changes. It only ever does the first note that's in there. We must have not taken our Jimmy out of our note. Where do we do? That is so jacked up. What is going on? First thing I'm going to do is go back to our conf and make sure we turn off our console, because that screws up a lot of things. Then I'm going to detach from tmux, and I'm just going to load in again and search for self.jimmy, because that was not showing up. And there, now it's in there. So now we should get that 1. Nice and solid 1. And we took off the freaking console. Let's go back to our conf here. Man, today has been not very good. Okay. We've got our 1, but the thing is, that doesn't count how many notes are coming down the pipeline. It just counts the first note in... It just counts the first note and how many fields are in there. And Puny, here is the class here. So we've got 7 fields. And all we do is really update its X position based off its speed. And then we render a certain fret drawable depending on which fret it is. where you populate the active nodes. In our play state, we go active notes. So we start with an empty table, and then right here. So we loop. Gosh, yeah, this has got to be where we screw it up. We're saying if there is a value in our song 1. Actually, I don't know what the hell we're doing here. This is wrong. I think what I'm doing here is saying if we still have a note left in our song 1, since we remove the index, we remove the first index from our song 1 at the end of every loop here. So if we still have a value in song 1, then what I thought I was doing here, song 1 is every note being played at the time. No, song 1 is the table of all the note instantiations. So song 1 is right here. Where are we, man? Song 1. Song 1 is right here. It's the table of all the note instantiations. So like the first note is a table of notes for the chord. So there's 3 notes in the first index of song 1 for the chord. Second note is right here. So as song 1 progresses, we say, you know, every time we go to insert a new song into the active notes, and active notes is what's on screen. Yeah, go ahead. All we do is take the first index of the song 1. So it would take this whole table. We're supposed to insert all of those into the active notes. And then we're going to delete that from song 1 so that we can continue to play the next notes. But also, I did this before I understood that the number operator worked differently than I thought it did. So now I'm not trusting these lines of code to do what I'm expecting it to do. Because anytime we ask for the number of song 1 at index 1, it should be 7. Why not make it always a chord? The difference is just the amount of items, so it's always a list of notes. I guess I'm thinking of it as when I go to type in the song once I write it, I don't want to have to type in empty chords, because most of the notes aren't going to be chords, since chords have to be the same frets, in just the way I did it. So the difference is just the amount of items, so it's always a list of notes. Yeah, I guess I just don't want to do... Yeah, I guess I just don't want to fill in mostly empty notes, you know? That just feels kind of weird to me. But also, this is just so jacked up. Because I think... What I used to think this number was doing was saying, if the next note in our song is a chord. But what this really is saying if the next note in our song, which all of the notes in our song are a note instantiation, and each of those have 7 fields, so this will always say if 7 is greater than 0, not if... this is weird. Yeah, we did this jacked up. This is jacked. So this was supposed to be if there's a chord, but we don't have a way to do that at the moment. Man, I'm gonna have to really kind of work on this. Yeah. No, I get that it doesn't really matter. It's just that when I go to type it out, I don't want to have to put every note that isn't played as an empty chord, because you're saying every note is a chord, but the chord would be one fret and one string, and then not any other frets and not any other strings. Only if it has at least one note. Yeah. I mean, are you thinking, like, if you were doing the song here, you're saying instead of putting this as a table of note instantiations, you're saying, why don't we just have every note a list of which, well, fuck. Like we would change note to be all the notes, not just a single note, so that every table is one. Gosh. I don't know, man. Because yeah, you're saying instead of this one being one note, you're saying, why don't we make this a table of all the notes that it is? Every indices of one would be a chord. Every index of song one would be a chord. Yeah, so we would change our note, because what gets tricky is, like, we need to register notes independently from one another. So if everything's a chord, I think we would still need to. It's hard for me to wrap my head around this, because I built it out with notes in mind first, not with chords in mind first. Every index of song one would be a chord. So I think I need to do some thinking about this number operator and make sure I'm understanding it correctly. Oh, Jimmy's on the move. I got him. Got the Jimmy butt cam going. All I know is I was grossly misunderstanding what the number operator does. See, so it's just that this doesn't work when I use it with classes, which it's working more like this one when I use it on a class. Imagine it as a JSON object. So are you saying that, I mean, what are you suggesting we do with our current note class? Are you saying we should change it to be a chord, and every chord is a table in itself, so that we can have the same amount of tables? Well, yeah, I don't know, man. Because we have to be able to we have to use the class, right? Because we have to track which note is where and update its position. Like, like what? This isn't using the same class library I'm using. What is the class library I'm using? Oh God. Why? Okay, this is just gonna confuse me more. You know, I'm not sure what to do. I'm not sure what to do. The big thing is we figured out that we can't use our number operator how we thought. So Puny, I'll try to wait. What? Yeah, I'll try to think about what you're trying to suggest we do here. I'm just confused because we know that as soon as we put classes inside of a table, I don't know how to keep track of which one's which. Let's try something here. Let's try to print up, like, let's forget about active notes right now, and let's just try to go into the first note of our song. So let's just say, you know what, screw all this. And what we want to do is print up song 1 at index 1. And then I want to say we do another index like this for the first one and then dot string. Okay, we remove it. Okay, we have to stop removing song 1 once we insert it. So let's stop removing song 1 and let's just stop inserting active notes for the time being. Okay, I mean, yeah, we just only ever have that first. Okay, so if we go into the second string, I believe in our song 1, our string should be 1, 2, and then 3. So index 2 should be a 2, which it is, and 3 should be a 3. Okay. So once we put this... Okay, sweet. I'll check that out. I think we might need like... Okay, so Puny, you're saying a table of chords, and every table is a chord of all the whatever notes. So the items inside the song 1 will always be an array. Okay. So if... Okay, so then we would know that every note, we need to insert all 4 notes into our active notes before we delete them from song 1. And then we'd be able to... I guess I just don't get why what I'm trying to do can't work. Like, I don't get why we'd have to do empty chords. So we are able to at least go into our song 1 at index 1. Okay. So why can't we do the same thing with our active notes? That's just what I don't get. Thank you for sending that, Puny. I'll consider that if I can't dig into why this active note thing isn't working for me. And I think it's just because we're inserting them wrong, because we were inserting them here. So let's redo this, and we'll just try it again. So if our song timer has decremented past 0, we want to first copy song 1, index 1, all of it, into our active notes. And then what we want to do is delete song 1, index 1, so that the next time we go to insert song 1 at index 1, it's the next note. So all we have to do is say table.insert into our active notes table our song 1 at index 1, which should be either a table or a class. So I think, so Puny, you're saying if we always insert a table instead of a class, we'll be able to index those individual things. So if it's not a chord, if it's just a note, then it is a class, and we aren't able to index into it because the number table, the number operator, goes into the init fields instead of the number of chords. Oh my god, okay. I think that's the way, Puny. I think you're right. I did not see the last message. You can iterate over every chord. If the number of song is greater than 1, it's a chord. Yes. See, that's what I've been trying to do, but it didn't work with the note instantiations or the chord. Yeah. Okay. I think that'll work, Puny. I think that'll work. It's just that, I guess, let's take a look at our note class. Now we don't have a 0 fret or a 0 string, but that's okay because we just don't do anything if it's a 0 fret or 0 string. So we should be able to do what you're saying, Puny, and just do a note 0, 0 for whatever. So let's try to do that and see. So let's clear this, right? So now let's just try to do one chord, and we need to make sure that we put it in a table so we know how to index it. And we'll say the first chord is 1, 1, 1. Now, the third one in the parameter is how many seconds to play until the next note, but if it's a chord, we shouldn't be modifying. Gosh, this is getting crazy, but I think let's do 2, 2, and then also 1. And then we'll do 3, or let's just try to do 0, 0 for how we would put in an empty chord. See, and then I guess I'm just like, you know, if the song is 50 notes long, then we have a 200 notes we have to type out to write the song, which kind of sucks, but also if we can't get them rendering right, it doesn't work at all. So now we can index into the note by saying song 1, index 1, or index 2, or index 3. That's not right. I think I did what you said. Okay. Yeah, like the so now let's try to insert the correct note into our active notes. So we will put we can do a for loop here for all the notes in the chord. For I gets 1, 4, do we want to insert? Oh man, because we're trying to insert all of this, like song 1, index 1 is a table of all the notes. Okay, well maybe we don't have to do that. Maybe we just do song 1, index 1, that should be a table of 4 notes, and we put that into the active notes. So that should give us an active notes table that is one table of 4 notes. And then what we can do is say table.remove from our song 1 and the index 1, the first song we want to take out. Okay, do we crash here? Yeah. Where do we crash? 22, expected near notes. We forgot our closing parentheses, or closing curly brace upon our notes. Song 1. Did it say 22? Okay, well we have... Oh, we need a comma here. Okay, let's try that. Okay. So play state 87. Man, I hate the console screws up my terminal every time. Okay, so for pairs in active notes, it doesn't like that we're trying to... Was it 88? Where did we crash? 87, update a nil value. Crash right here because the value of our active notes. Yeah, I think if... Let's just only do this if... Gosh, man, I don't freaking know. I don't know. So it can't update the value in our active notes. Oh, I think we have to go through... Shit. Okay, because our active notes would just iterate through the table, but not through every object in the table, which is where our... Yeah. We need to do another loop in the active notes to actually update each note in the active notes. Jeez. This is just nuts, man. In pairs V? Okay. Let's spell these out so we're not losing our mind here. For key value in pairs active notes, we're gonna then loop through each note or index note in pairs of value. Oh my god. Is that right? What the hell? So this will loop through each index, each table in our active notes, and each table will have 4 notes. Then this one is looping through every note in those, god damn it, yeah, in each of those sets of notes. And what we want to do is then update the note itself here. And then, if the note's X position, if any of those X notes positions are smaller than 12, we want to remove it from the active notes table at the index, right? Oh God. Let's see. We want to remove just the note. So we want to remove from the active notes table at the, I think at the index, and we want to remove just the actual note. Oh my god. There's no way that's right. Okay, and then we need to do the same thing here. Gosh. Okay, whatever. We'll just get rid of this. It doesn't matter. You should use I pairs for an array. Oh, hey, look at that. We got the chord going. I pairs. Never used it. Never used it. I pairs. Let's see. Yo, I've never used this. For I value in I pairs. So pairs is just for like a table, but I pairs is for an array? I'm not exactly sure what the difference is, but I will look more into I pairs. Thanks, Puny. I pairs always expects a number. Okay, cool. Okay. So anytime we go through this, it should be I pairs. Key value in I pairs active note. So the key should always be a number, an iter or a number. And then same with this. Same with this one? I don't know, dude. Okay, I mean, hey, we got a chord on there, and now we should be able to render. Ay, ay, ay. So why do we crash there? Are we not removing it correctly? $91, bad argument 2. Okay, so we're trying to remove... We want to remove... the key, the note, or the... Gosh, we want to remove... What the hell, man? What value are we trying to remove from the key? We're trying to remove... Or from the active notes. We're trying to remove the whole object, so the whole key. And we want to remove it at the index of... 1. Right? We're trying to just take out the first index. Thanks, Puny. I will look into more eye pairs. Okay, we don't crash at least. So now we should be able to loop through every note and be able to touch it and change which color. I'm not gonna lie, haven't streamed this long in a while, and I was thinking today was gonna be super short. But we jacked up a lot of stuff. Thanks for helping, Puny. I did not know that you couldn't just index into a class like that or whatever. It's just, it functions a lot differently than I thought. So I think I might just do some thinking and see if we can figure out a better way or like a different way, because it's like, I don't like the fact that if we want just one note, we'd have to put in 3 empty notes for that first note. I just don't like that. Active notes key. Oh yeah, because the key is going to be that index of the active notes. Okay. Yeah, so active notes is the table, key is the index of which to remove. Yeah, cool. Thanks, Puny. Yeah, the whole chord. Yeah, cool. So yeah, I just don't like that if we have 3 notes, we have to put in 12 12 notes total. Like if we just have C, D, E, we'd have to put in 12 notes just to get C, D, E rendering, right? So like, I want to see if there's a different way we can do that. But I don't know, it's just because I don't want to type out 12 notes when we only want C, D, and E, you know? I don't want to have to type out 9 empty notes just so that we can say C, D, and E. So we can just put the note... Oh, yeah, I guess. Okay. You know what, Puny? You're a lot smarter than me. Because, yeah, well, we're not rendering all 4 notes. We're only rendering 3 notes right now. So that's kind of weird. We should be rendering all 4 notes. Yeah, why are we only getting 2 notes here? We're getting 1 and 2. Are those the first 2 notes? Yeah, 1 and 2 are the first 2 notes. Oh, well, we put in the 0 here. Okay, god dang, okay. So if we put in 3 and 2, then we're still able to put in only 3 notes. Okay, Puny, okay. Thank you, Puny. So yeah, we are able to put in... I don't know why I was so stumped on that. Like, okay, so every note, every index in our song is a chord, like Puny said. Yeah. Yeah, you're right, Puny. That is the way to do it. That is good. Because, yeah, we don't have to put in... So, like, if we wanted to put in a second note here, we can just put in one note. And we can just put in... We have to put it in a table. But then we can say note at... Let's just do 4, 4. And then we should have 2 notes now. And 1 is a chord. There's the... Oh. Shit. Okay, we have to look at when we were doing the timer stuff. Oh, man. Oh, man. Where are we doing the timer stuff? Oh, here. Yeah, I'm curious what we used to be doing for setting the timer, because I think we might have deleted that part of it. There, that timer. Okay. Okay. So what we used to be doing is we insert each... Oh my gosh, yeah, and then this is the old way we were doing it. We set the song timer to be equal to the timer of the first chord's dot timer field. And then yeah, we should just need to do this to get our timer back. So we should be able to say song timer gets set to be the first note's timer, and then we might be good. So let's do song timer gets the song. Now every index of each note should have the same dot timer, so we should just be able to go into the first note of the first table and assign the timer there. Is that correct? Yes, we're looking for that, and then the next one. Okay. Oh, and then we crash. 82. Okay, well... You can use it like this if you need to specify the index in each chord. Okay, I did not know you could do that. Okay, no, that makes sense. Yeah, to give it a specific index. I don't think we need to, but it's nice knowing that we can do that. We do need to figure out why song 1. Okay, so as we remove, okay, we need to only do this if we have a song left, right? So we did have this same kind of thing if the number of songs at index 1 is greater than 1. So if we have a value in our song 1 left, then we do that stuff. Then we remove the table. Okay. So if play state, we can say if the number of our song 1 at index 1 is greater than 0, then we want to do this stuff. And this was just the pseudocode. Okay, let's try that, and then we remove the table at the end. Okay. Shit. Length of a nil value at 79. Gosh, man. I'm just like... I don't know, dude. Every time, it'll still crash. Every time I do that, it still crashes. So... how, like, we can't do if the number of active notes is greater than 0, if we have an active note in there, then go ahead and remove, insert, I don't know, man. Fuck. Okay, we're not crashing there, and then they just disappear. So we're removing them too soon. We should be removing the whole chord, not the... Oh, maybe we do index here. No? Shit, man. If our note goes off screen, we want to remove that whole chord. So we go into our active notes and we go remove the key. So why does that remove both notes? Shit. So as soon as that first note's off screen, both disappear. Yeah, Prosto, this is not the norm for sure. Yeah, not the norm. I've just been super stuck on this crap. I don't even want to show you what I've been doing. That's just embarrassing, man. Yeah, not going very good. Active notes at index key is the table.remove, right? Yeah, because we're trying to remove the whole chord once the first one goes off screen or whatever. Yeah. Well, hey, thanks for stopping in, Prosto. It's always fun to see you. I said that when you were checking if the song ended. So, I mean, no, I still think... I mean, clearly it's wrong, but I was thinking that, yeah, we want to remove the first... I mean, yeah, we just want to remove the first active note, like the... Shit. Because the second note in there should be another table. Yeah, it's another table. Shit. Yeah. Hey, thank you, Prosto. There are plenty too many bugs in the program right now that I'm doing. Yeah. Thanks, man. Hey, you have a good night. Or a good morning, actually. Yeah. Okay, so if we just don't remove this, they should not disappear anymore. What the? Yeah, 7 a.m. Well, hey, good morning. Have a good rest, yeah. Okay. Okay, so this is every chord in the song, and this is every note in the chord. And then we update every note if the note is off screen, then we're going to remove from our active notes the first index. But then I guess this loops through. Oh, this would loop through. Okay, we need to do this outside. Yeah, we have to do this outside this loop. But we don't have access to the note. Shit. All we have to do is say if the index of the active notes at index... Oh my son of a... What? If active notes index 1, note 1, dot x is off screen, then remove that active note. No, Puny Megas? Didn't work? Looked like it worked. We update every note in the chord. Then, because I thought that this being in here was removing the first active note and then it was removing the second active note. Oh shit, I don't know. We have to do this outside of both loops, so we don't accidentally remove more than one active note? I don't know. Why did we crash there? Okay, I don't know. I don't know. I'm reaching that breaking point of like, I'm about to be not useful programming here. So if we print up how many active notes we've got now, let's just see. Okay. Okay, I mean, I don't know, looks right. That looks right. Okay, yeah, I think I'm gonna tidy up some stuff here in the play state and then call it a night, because, oh lordy, where are we even looking, man? Yeah, we need to put this all out of our play state so that we don't have all of this junk. Your logic was right with the if inside the loop, but pairs is not ordered. It would be better approach to use an indexed loop. For the, are you saying you use I pairs here? Or for a 1 comma, like a for loop instead of a one of these loops? Your logic was right. For k is 1 to active notes, do active notes. Active note gets active note k. So if you're inside the loop, okay, so is this, are you saying for both of these or just for the every note in the chord? Has to be a while? Okay. I guess I don't get why it would be better to do the other 4. Are you talking about like performance-wise or bug crash-wise? I don't know. Because this seems to be working okay. We didn't get to fix any of the rendering stuff, but at least now we can index all of the chords in our song. It is. I think it's working. I think it's working because I think so. Now, all I wanted to do was try to set. And let's just do this in the update function. All I wanted to do was set active notes. Well, if we have an active note, I just wanted to be able to set individual notes to be green or red. So active notes at index 1 dot valid timing gets true, and then let's say this would crash outside, like as soon as we get that second note on there, or as soon as the first note disappears, this would crash. But I do want to say that the second note, invalid timing, would get false. Let's just see. Okay, that's not quite what I wanted. We got the first note to be green. Oh, I think I... Oh, yeah. What the heck? Okay, we can change that one. Why can't we change the second note? Active... If we have an active note, we set the... That should be the first note. That should be this. Oh, invalid timing to false. Okay, so let's set the second note in our chord to be true invalid. That's just confusing. Okay, now we still have two red. Oh, god damn it. Okay, this is valid. That is unvalid. We should have a red and green. And if we have a red and green, then that does something that we weren't able to do today. So thanks to Puny, we can actually, and I knew it would crash there. Thanks to Puny, we can now change individual notes of our chord to different colors. But also now we can actually touch other than the last class instantiation. So like we used to be putting every note into a table, but not every set of notes into a table. So when we were trying to index into a specific note of a chord, we were only ever able to touch the last note of the chord. So Puny helped us figure out that doing it this way means we can still declare one note at a time, but every note is now indexable because we put it in its own table. So that was a long time to figure that out because I thought the number operator worked differently than it did. It only really works for length of tables, not for length of classes. So we were getting a totally wrong number trying to use the number operator on a class instantiation. It was giving us the list of fields within that class as opposed to the amount of class objects in that specific index, which is what I thought it was doing. So tomorrow we can actually work on what we tried to work on today, which was we want to get correct notes to be rendered green, incorrect notes to be rendered red, and then we need to count how many correct notes we get and do that whole shebang. So we will call it there because I'm fried. But yeah, we now render each note in the pair of active notes. instead of just render, we do it in, we have to do a nested loop here because every note is inside its own table. So instead of just saying for key value in pairs, now we're doing the I pairs, and then we're cycling through every table within every active note table. So, geez. And then we'll work on selecting, a song so that we can pick a different song, and then we'll try to work on getting, a song selection as well as the bass note stuff working, because the way the tablature is going to work is we get a list of bass notes, and once you play those notes in the correct timing, it'll go and loop. It'll be like a loop station, and then you play the melody over the bass notes. So we'll have to add that to our song as well as we'll have to figure out how to factor our lute song out of our play state so that we don't have it bogging down our whole play state. So we might put it in its own state. I don't exactly know, but we'll figure it out. Let's do what we did today, which was and actually I want to turn off our conf debug here. And then we'll git add everything again. And we will commit with a message saying changed lute notes into individual tables for indexing. That's about all we did, but we learned a lot today. Thanks to Puny. So yeah, thanks, man. And then, let's see, we've got Basie maybe making a game here that we can raid. Let's see. Yeah, it looks like he's doing some table stuff just like I was, so we'll raid Basie here. But thanks for watching, everyone. Sorry it was a slow, crazy, tough episode, but you gotta have those. But yeah, have a good night, K-Tron. We'll raid out Basie. Thanks for watching. I'll be here tomorrow, and we'll get some more productive work done. All things considered. Yeah. Thank you. Thanks for the help today, Puny. I appreciate it. I hope you have a good night or morning wherever you are. And I'll catch you guys later. Yeah, I'm hoping I'll feel better tomorrow. The weekend is helping me. But yeah, peace out, guys.